Section 6. Decoupling for cross-platform behavior. Unity GUI components and layout. The Unity UI system should not be confused with the old GUI system called IMGUI, also known as immediate GUI mode. The core of the Unity GUI is the canvas component. The canvas component serves the same purpose as a 2D or 3D renderer in Unity. It renders the GUI components, which are its children. A canvas has a canvas render mode, which can decide how a canvas will be rendered. A GUI can render in screen, camera, or world space. A screen space camera, as the name suggests, will use the 2D plane defined as the screen for its coordinate system. The camera space renderer will obey information such as distance from the camera's perspective and rotation, but it will still operate as if the origin of the scene is where the camera always resides, regardless of where it is in the scene. Several canvases may be used at once, and they may be configured together using a canvas group. A canvas group can be used to do things like set opacity and toggle whether a group of canvases will accept input. Attached to the default canvas object is a canvas scaler. The canvas scaler can be used to scale your game's UI relative to a reference resolution. This is useful for deploying across devices with different screens. The canvas scaler may operate in 3 modes. With a constant pixel scale, no scaling is done. For the screen size scaling mode, the UI elements will try to adapt by scaling from a virtual reference screen size to the size of the target device. The screen size scaler will respect aspect ratio and will try not to distort GUI elements. The constant physical size scaler will attempt to adapt an element size to the physical size of the device. Whereas a pixel refers to the amount of data in an image file and says nothing of how many of those pixels will be rendered to a physical display, a physical display refers to the display element of the physical screen as dots. Regardless of how the UI is being scaled, UI elements are positioned on the screen using anchors. The position of the anchors are shown as 4 wing-shaped widgets. Each wing represents the corner of a rectangle that a GUI element. As the GUI canvas changes, the element will scale and move to match the box specified. As this seems counterintuitive, Unity provides a number of preset anchor modes, accessed by clicking the cross icon in the GUI element inspector. The presets allow you to anchor to any single edge or corner of the screen, with or without scaling. You can scale relative to the horizontal or vertical axis and anchor to a point in whichever combination you choose. The icons with blue arrows show which directions of scale will be used. The red lines show which edges the reference rectangle will become anchored to. The visual elements of the GUI include text, images, and raw images. The image element expects sprites, so it has the same properties as a sprite renderer in the Unity 2D pipeline. The raw image mode only expects a single image, which does not need to be imported as a sprite. The text element allows text of an arbitrary font and resolution to be drawn. It is common to keep text at a fixed size so that it is readable on all target devices. Scaling the text itself after it has been rendered to a bitmap may introduce rendering artifacts such as blurriness or sharp edges. The interactive elements are familiar from everyday computer use. They manipulate visual elements and send and receive values to scripts. A button sends a message when clicked. A slider may be used to set a value, or as a progress bar if you disable its handle. A toggle represents an on or off switch, or may be used as a radio button for simple choices. The drop-down can be used for a longer list of choices. The input box accepts a text entry. Longer views can be encapsulated within a scroll view. Screen size and orientation can change depending what device is running your game. To accommodate this is the auto layout system. The auto layout system will try to adjust the position or scale of objects to fit the available space. One common problem is that mobile devices have landscape and portrait viewing modes, and the GUI may need to rotate to accommodate this. To the right, an example of the horizontal layout engine is shown. When the screen size changes, not all of the boxes fit within the available space. Thus, one is pushed to the line below.